Okay, so now we're going to tackle question 20 from your applications of vectors sheet. So again, this is for Physics 12-2 at James M. Hill. Or anyone who wants to see how to do this problem, great. I hope you enjoy it. It's real exciting. Canadian submarine, 185 kilometers, east 22 degrees south of Halifax. Just kind of sitting there, hanging out. Enemy sub spotted 425 kilometers, east 67 degrees north of Halifax. Sub's heading directly towards it, Halifax, at 45 kilometers an hour. So if an enemy sub is going to attack one of our eastern cities, yeah, it'd be Halifax. That'd be my first choice too. No, I love Halifax, really. What minimum velocity is required for the Canadian submarine to intercept the enemy sub 200 kilometers from Halifax? Lots going on in this question. It's a good question for critical thinking and problem solving because there's a lot of little steps to it and you have to do them in the right order. So it's kind of a start with what you've got and work your way towards the end question. As always, if you can, it's helpful to do a diagram. So there's our Halifax right there. Black dot represents Halifax. Great city, a lot of places to go, a lot of fun to have there. And this little line, it's going to represent the vector for the displacement of our Canadian submarine. Right there. 185 kilometers. 22 degrees south, east south. Okay. And now we'll use this line over here. That represents the displacement of the enemy sub at its current position right there of 425. And the dashed line, I'll bring that over to the problem. This represents the displacement that the Canadian sub needs to make. Again, not to scale, it doesn't necessarily have to go due north, but this is the displacement that the Canadian sub has to make. Once we know the time the Canadian sub has to be at this position by, then we'll be able to calculate the average velocity. So once again, the Canadian sub needs to get to that red star. It needs to get to a point 200 kilometers from Halifax along a direction east 67 degrees north, same as the enemy's sub direction. And we want to find out the minimum velocity to make it to that point and intercept this enemy sub and blow it out of the water or do whatever it is they do. So to figure out the time it's going to take the enemy sub to get to a point 200 kilometers from Halifax, it just kind of falls back onto the average velocity equals displacement divided by time. Okay. So rearranging this equation, the time equals displacement divided by your average velocity. So remember, this is for the enemy sub. It's got to go 225 kilometers. Remember, it's not 425. The full length from here to here is 425. The enemy sub is just going from here to here. That's 225 kilometers. And it's moving 45 kilometers an hour. So, in other words, the enemy sub will be 200 kilometers from Halifax in 5 hours. So that's how long the Canadian sub has to get there. So once we know the displacement, we can do displacement divided by 5 to figure out the average velocity the Canadian sub needs to maintain. Okay. So, summarize that again. Oh, let's move that down a little bit. Summarize that again. The resultant displacement of the Canadian sub needs to be this. East 67 degrees north. Okay? That's the resultant displacement of the Canadian sub. We're trying to get to there. Now, if you look carefully at the diagram, kind of again, like problems we've done before, it makes a triangle. So I'm going to call this D1. I'm going to call that one D2. I'm going to call that one D3. And I usually just name them by starting at the my starting point, Halifax, and follow the two arrows that are connected together. So I'm following the arrows from Halifax down to the Canadian sub's current position, and then the dashed arrow up to the line where they end up there. Okay. So vectorly, D3, the resultant displacement is its initial displacement plus the displacement it has to go to get to its endpoint. Rearranging, like we have in other problems, it'll be the resultant position, subtract the initial position. That'll make sense. Where you want to end up, minus where you started, tells you where you need to go, kind of thing. So just kind of write that in a slightly different way here. That position needs to go is the final position, 200 kilometers east 67 north, or it's from Halifax, subtract its current position, 185 kilometers east 22 south. So we do this equation by breaking it up into its east components and its north components. We can't just subtract them and go 15 east 45 degrees north south or whatever the heck that would be. It doesn't make any sense. So we have to break them up. So the displacement that the Canadian sub needs to go in the east is going to be 200 cosine 67, and then minus 185 cosine 22. So remember that eastern component is already positive, but we're subtracting it, so it stays as a subtraction. So that works out to be negative 93.4 kilometers. So in other words, from its current position, the Canadian sub has to go a bit westward. Now we're going to do the same thing for where it needs to go in the north. Resultant displacement in the north. So that's going to be 200 sine 67, where it wants to end up, subtract negative 185 sine 22. Negative 185 because it's already in the south, but the double subtraction makes it positive, which makes sense. The enemy sub is north of the Canadian sub. It has to go a positive displacement. It has to go north. So that works out to be 253.4 kilometers. So from its current position, the Canadian sub needs to go 93 kilometers west and 253.4 kilometers north. We can summarize the direct line path using Pythagorean theorem. The Canadian sub isn't going to go one direction, then turn and go up the other direction. It's going to go the path of the least distance, and that's going to be the straight line path that we get by doing this kind of Pythagorean theorem step. That works out to be 270 kilometers. So the Canadian sub needs to go 270 kilometers of distance, and then we need to know the direction. As always, direction inverse tangent of component north over the component east. That works out to be inverse tangent then of 253.4 over 93.4. That gives you 70 degrees. Okay. So we have our displacement. The Canadian sub needs to go 270 kilometers out of direction west, because it was negative, 70 degrees north. Kind of makes sense. So if I had drawn this to scale, you would have seen that arrow, the dashed arrow up here, I'll scroll up, leaning a bit more to the left. It would be going west. Average velocity is the displacement the Canadian sub needs to go in the time allotted to do it. So that's going to be 270 kilometers in 5 hours. So average velocity of that Canadian sub is then 54 kilometers an hour at a direction of west 70 degrees north. So if it goes at minimum that speed, it will get to that point in the ocean at the exact same time as the enemy sub. thus rendering the enemy sub defenseless and destroy it, and sure, a naval war combat that would end all naval war combats.